Okay, so Unit 11 is all about area, surface area, volume, perimeter, you know, the nice things. So we will talk about that we are going to be using formulas. Do you need to write this down? No, I'm sure you know the definition of a formula, but we're just going to talk about it. A formula is a statement, and especially it's an equation, that is a fact, a rule, a principle, or another logical relation. And formulas in math are ways to find values, right? So we have formulas for area, we have formulas for volume, we have formulas for surface area, we have formulas for perimeter, we have formulas for circumference, we have formulas for speed, I mean everything, right? There's formulas for everything. Also, these can be known as an algorithm as well. You hear that? Algorithm is also another word for a formula. Okay, area is the measure of a bounded region on a flat surface. So area is always flat, and it's the amount of flat space something takes up. So 2D. So if we have, you know, like a rectangle, the shaded bit, that's the area. Perimeter is the sum of the lengths of the sides of an object. So this is the length around the outside. And these do sometimes get mixed up. So the perimeter then, of a square is going to be this length plus this length plus this length plus this length. So around the outside. Okay. Right, every bounded region has an area which is a unique positive number. That means like this piece of paper right here has an area and it is unique and it is positive, and no matter how I try to calculate the area of this piece of paper, I will always get the same number. The area of a rectangle is the product of its length and its width. So piece of paper, 8.5 by 11. Well, 8.5, yeah, so it's 88 plus another 5.5. So 93.5. Yeah, you're subtracting. 93.5 square inches. And that's the other thing. The units are squared for area. That you should know that. Okay. So we have a rectangle. We have a length and we have a width. Does it really matter if I call this length and I call this width, or I call this width and I call this length? No. One of them's length, one of them's width. That's all that matters. The perimeter is adding up all the sides, so I have 2 lengths and 2 widths. So 2 widths plus 2 lengths. If you don't remember this, just remember to add them up, all 4 of them, and that's fine too. And then the area is length times width. Good? We're going to find the perimeter of this rectangle. Perimeter is 2 times the length plus 2 times the width. Now I have to do some complicated calculations. I don't know what they are, so I'm just going to say units. Perimeter is in just units, not squared or cubed or anything like that. So not. So far, so good? Kind of lost you guys? The area. So if I have a rectangle that is 3 feet by 6 feet, I could break it all up and count up how many little tiny squares of feet that was. And that's why they're called square units, because we count the number of squares that are 1 unit. Or 3 times 6, which again is some complicated calculations. And I have square feet, 18 of them. Yes. But it is on the end of course exam, so we're going to go back over it in case somebody doesn't know all the formulas. Okay. Now we do get a little complicated though. I need to find the area and perimeter for this rectangle. I only know the width and a degree. But if this is a 90-degree angle and this part's 30, this is 60, and this over here is 30, and I have a 30, 60, 90 right triangle, and we have a pattern. So this is going to come back up again. If I have a 30, 60, 90 right triangle, my short leg is A, my hypotenuse is 2 times A, and my long leg is A times the square root of 3. So this length is going to be 2 square root of 3. Okay. Now to find the perimeter, I have 2 times the length plus 2 times the width. So 2 times the square root of 3 plus 2 times 2. So I can leave it like this. This is a perfectly accurate answer because this is 100% accurate, because if I find the decimal version of the square root of 3, it's an approximation, right? Because the square root of 3 is never, it's an irrational number. It's a never-ending, never-repeating decimal. So you can stop right here and have a perfect, we'll just say inches, so we'll just put inches, perfect answer. Or we can take it a step further and do the approximation, which I don't have the square root of 3 memorized, so I'm just going to put it in the calculator real quick. Square root of 3 is 1.73205080, blah, 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 blah. So I'm going to just call it 1.7. Okay, so I have 2 times 1.7, which is 3.4. So this is approximately 7.4 inches. Okay. If I'm doing the area, that's length times width, so I have 2 times 2 root 3, which is 4 root 3. And again, I can leave it like this, or I can do the approximation, which I already did over here anyway. So, well, no, it's, I did that wrong. Look at there. See that? That should have been a 4. I had a write down the wrong number moment. Hold on. Let me fix this. 4 times 1.7 is 6.8. So this should be 10.8. So yeah, be careful you don't do what I did, which is write this down here instead of that way. So this is about 6.8 inches squared. Okay, so it actually equals 4 root 3, but it's approximately 6.8. Okay, so just again as a reminder, we have our 30, 60, 90, and our 45, 90, where these are both the same, and this is times the square root of 2. Okay, so make sure if you don't already have those that you have them now. All good? Oops. Okay, we can look at something like this and we can find missing information. So here we have a length and a width, so we can fill out the area. We just take 13 times 8, and we get 104. Or for perimeter, I have 2 times 13 plus 2 times 8, which is 26 plus 16, so 42. Okay, so this one pretty straightforward. Sometimes it's not as straightforward, so I have a length and I have an area. Remember, area is length times width, so x squared plus 5x is equal to, sorry, minus 5x. equal to x minus 5 times w. So I have to figure out what do I multiply this by to get, or what do I multiply this by to get this? Well, if I factor out an x here, x squared divided by x is x. 5x divided by x is 5. So w has to be x. Does that make sense? Want me to go over it again? Yeah, so I'll just go over it again. Area is length times width. I know the area, and I know the length. I don't know the width. So what I need to figure out is what multiplies times this to create this, and so I started factoring, because these both have x's, so I took an x out. And x, that's too far over. X squared divided by x is x. And 5x divided by x is 5. And now I have that x minus 5 that's the same. So x times x minus 5 is equal to x minus 5 times w, means that w has to be x. Is that better? Okay, so w is x. Now I know the length and the width. I can find the perimeter. So 2 times x minus 5 plus 2 times x. This is 2x minus 10 plus 2x, so 4x minus 10. I don't have a set value for that. I'd have to know what x equals, but I can still find the information that I'm missing. Okay. And then we have these non-rectangles that are made out of rectangles. And I can break this up two ways. I can break it up here and have these two rectangles. Or I could break it up here and have these two rectangles. They're both doable. This breakup has less work necessary than the other way to break it. If I break it here, I have a 5 by 5 square and a 5 by 15 rectangle. If I break it the other way, here, this is now no longer 15. I have to figure out how long it is. And I know that this is 5 here, so I'd have a 10 by 5. So this is 5. That would make this 10, and that would make that 10. So do you see what I mean? I'd have to figure it out. So personally, if I'm personally doing this problem, I'm breaking it up here. So I have a 5 by 5 and a 5 by 15. Because then I didn't have to figure out any lengths. Like, it was already figured out for me. So my area is length times width plus length times width, because I have two boxes. So I have the 5 by 5 and the 5 by 15. So that's 25 and 65. So the area in total is 90. And I don't know so I'm just going to put units squared. Then the perimeter, I have 2 times the length plus 2 times the width of the first one, and 2 times the length plus 2 times the width of the second one. So I have 2 times 5 plus 2 times 5 plus 2 times 5 plus 2 times 15. So 10 plus 10 plus 10 is 30. Plus 30 is 60 units. Okay. Here, same deal. I can break this up. I can put one line down this way, and I can have a long, skinny rectangle and 2 smaller rectangles, or I could break it here and here. Either way, on this one, I'm going to have to do some calculating to find out the lengths. So do you want a vertical line and have 2 and then a long, skinny one, or do you want horizontal lines and have 2 and a little, skinny one? What makes the most sense?
Probably go for the long one.
The long one? Okay. what I have is this part right here is a 12 by 6. This part right here is a 10 by 12. This is 10. This is 14. That means this part's 4. And I can verify that up here because this is 6 and this is 10, which also gives me the 4. So I know I have a 4 by something. Now I have to figure out, oh, well, the length. The length is already there. It's 36. 4 by 36. So I have 3. So my area is going to be 12 times 6 plus 10 times 12 plus 4 times 36. So I have to add up all 3. So 72 plus 120 plus 4, can I choose 144. So that gives me a total area of 336 square units. Now my perimeter is going to be a little bit, oh my god, I messed up the perimeter. Is it Monday? It's not Monday, is it? No. Here's what I did. I counted this line twice, actually, when I did the perimeter, because I did the 2 rectangles. But you don't do 2 rectangles, you do the perimeter of the whole thing. So let me fix that for you and do it correctly this time. So this part's 5, 5, 5, 5 and 5, that makes this 10. So my perimeter is 5 plus 5 plus 10 plus 5 plus 15 plus 10. I have to add up all around the outside. So 10, 20, 25, 40, 50. See, because I counted this twice, we had gotten 60. What I could have done, I could have done the 5 and 15. I could do 2 by 5, 2 times 5, but I can't do 2 times 15 because there's only one 15. So, you know, it's just easier to do it this way. And then this perimeter, so I have a 10, a 12, a 6, a 36, a 12. 12 and 12 is 24. I'm missing this part right here, but this whole height is 36. So if I have 12 and 12, that makes this also 12. So I have 10 plus 12 plus 6 plus 12 plus 10 plus 12 plus 14 plus 36. And I don't feel like doing that in my head right now. Whoa. So my perimeter is 112. 112 units. The area of a parallelogram is equal to the base times the height. Okay, now the biggest thing I see confused on this is that people multiply the side. Not the side, the height. Okay, the height has to be at a 90-degree angle. Okay. The area of a triangle is 1/2 the base times the height. Again, height is at a 90-degree angle. And 1/2 base times height for triangle. So parallelogram, area equals BH. Triangle, area equals either 1/2 BH, or if you prefer, BH over 2. Yeah. So base times height divided by 2. Just a matter of preference. They're the same thing. Again, area. Amount of space it takes up. We already talked about that. Okay. If we take a triangle on the left and to the right, we can see that we get a rectangle. That's how the area of a parallelogram was derived. So you take this triangle, you move it over here, you get a rectangle, and it's length times width. But the height becomes the width. So that's where you get base times height for parallelogram, in case you ever wondered, because it is. Fun, isn't it? All right. Same thing with a triangle. If we take an original, like we take this triangle and we copy it and put it next to it, we get a parallelogram. And the parallelogram is base times height, and the triangle is half of that.
Well, what if you just took the 1/2?
You could do that too. Yeah. So that's where that came from, though. So a triangle is half of a rectangle or half a parallelogram. So, in case you ever wondered where those came from, now you know. So we want to find the area of this triangle, and we are missing the base and the height. Yeah. So I say, okay, well, I can't find the area with just the hypotenuse. However, I have a triangle, and it is a right triangle, and I have a degree, and I know trig. So katoa. Okay, I have a hypotenuse, and I'm missing a height and a base. So I can take my sine of 52 is equal to the opposite over the hypotenuse. So sine of 52 is, okay, so the sine of 52 is 0.7880, and I don't know the opposite. That's the h for height, but I do know the hypotenuse, which is 16. So if I multiply times 16, my height is 12.61. So it says round to the nearest tenth, though, so we're just going to call it 12.6. From here, I can either now use Pythagorean theorem to find the missing side, or I can go ahead and stick with trig. I'm going to go ahead and stick with trig, because now I have the cosine of 52 is equal to a over hypotenuse. So I'm just going to calculate the cosine of 52 as 0.6157. I don't know the base, but I do know the hypotenuse is 16. So I multiply both sides by 16, and I get that my base is 9.9. And my area is 1/2 BH, or BH divided by 2. So that would be 1/2 of 12.6 times 9.9, or 12.6 times 9.9 divided by 2. Either way, my area is going to be 62.4 units squared. Okay, so don't forget SOHCAHTOA. We're going to calculate us some areas. Area, 1/2 base times height. This is a 90-degree angle, so I know one of them is the height and the other one is the base, because the base and the height are always at 90-degree angles to each other. So it's 1/2 of 8 times 12, so 48. Here, I don't know my height. I know my base is 10, 'cause this one will also be 10, so my bases are 10. But I don't know the height, but I can find the height because I have a 30, 60, 90 triangle. And I know that this is A, and this is 2A, and this is A root 3. Well, there's A right there. So my height is 8. So my area is base times height, which is 8 times 10, which is just too difficult for me to even contemplate. It's 80. I know. 80 units squared. B, we have a height, we have a base. Twelve times 22 is 264. Again, I don't know my units. Now this is where we're going to have a little more work to do. I have an isosceles triangle. Because I know that, because these are the same lengths, I know that these are the same angles, but I don't know what the angles are. But I can come in and make a 90-degree angle and make my height up the center, and I get 2 right triangles. Because this is isosceles, that means I know that this length and this length are the same, so these are both 3. So I have a 3, a something, and a 5. I can use Pythagorean theorem. So 3 squared plus, I don't know what squared, is equal to 5 squared. 9 plus x squared equals 25. So x squared is 16. So x is 4. So my height is 4. And my base is 6. Make sure you don't go using the 3. Or if you do use the 3, you have 2 of them. So I get 1/2 of 6 times 4, which gives me 12. Square units, because they didn't tell us units. So I'm just going to get rid of this altogether so that nobody wants to do it. They come in later and see that, they're like, what? So tomorrow we're going to do trapezoids and polygons, regular polygons of any size. Then we're going to do similar shapes, ratios of similar size shapes, and then circles. But the circles is circumference and area of circles, so it's not like pi r squared. So your homework tonight, which you guys have 20 minutes left of class. I cannot let you leave this early. But so you could probably finish this right now and not have homework tonight. Page 64 and 65.